In this question, we're told that a particle A of mass 7 kilograms is on a smooth plane inclined at 70 degrees to the horizontal. A is connected to a second particle B of mass 17 kilograms by a rope which passes over a smooth pulley P. We're given the extra information that particle A is held at rest and that the rope is taut. And we're asked to find the normal reaction force, the acceleration, and the tension. Okay, so as always in a question like this, we need to produce a well-labeled diagram. So where's the information for the diagram coming from? Here, the first thing we're told is that particle A has a mass of 7 kilograms. And we're also told it's the one on the smooth inclined plane. So there's quite a bit of information in these two phrases. Firstly, I can label A and I can label the angle. So 70 degrees is the incline and 7 kilograms is the mass of A. This gives rise to a lot of other information. If there's a mass of 7 kilograms, we know that there must be a weight of 7g. If we have an angle of 70 degrees at the incline, there's an angle of 70 degrees here. And we can now find our perpendicular components. So parallel and perpendicular to the slope. In these directions, we get 7g sine 70 and 7g cosine 70. So a lot of this came just from knowing 7 kilograms and the incline of the plane. Okay, continuing to label. If we have some weight and we're in contact with the slope, we have a reaction force. So here I know I will label this as R. This is the normal reaction force of particle A. Okay, so a lot on the diagram from these two short phrases. Continuing, we get some more information, this time around particle B, and that's 17 kilograms. So we can label that. Once again, it has some weight, this time 17g. And because we know that these are connected by a rope that is taut, we know there's going to be tension as a force in the rope. Okay, the diagram is well labeled and annotated. Let's go ahead and see if we can respond to the question. First, we're asked to find the normal reaction force. Well, I can resolve perpendicular to the slope for A, and that will give me an expression for R. So R is going to equal 7g cosine 70. Okay, into the calculator, and to three significant figures, I get 23.5 newtons. For the rest of the question, it is important to know which direction the objects are moving. Is A going up the slope or down the slope? B is going to move vertically, but is it moving up or is it moving down? The way we're going to decide is to compare the two opposing driving forces. For A, the driving force is going to come from the parallel component of the weight. That's 7g sine 70. For B, the driving force is going to come from its weight, 17g. And here we see that 17g is the larger of the two, so particle B is going to be moving down and particle A is going to be moving up the slope. Okay, so now that I've got that, I know the positive direction of motion, and I'll just label that onto the diagram as well. Okay, now to find the tension and the acceleration. We need to use the forces that are in the direction of motion for A, and then the forces in the direction of motion for B. For A, it's these two. It's the tension and it's the parallel component of the weight. So the expression here for F equals ma, that's what we're using. Now T is the positive direction and 7g sine 70 is the negative direction. So we want the resultant force, we're going to use F equals ma. So the resultant force is going to be T minus 7g sine 70. And that's going to equal 7a. Moving on to B, the two forces in the direction of motion are T and 17g. 17g is the positive, whereas T is the negative. So 17g minus T equals 17a. And we go ahead and we add both of these together. That will eliminate the T's and give us an expression for A. A is going to equal 17g minus 7g sine 70 all over 20. And this is actually the first time that I've picked up my calculator in this part of the question. The first time I've picked up my calculator. We didn't need to evaluate 17g or 7g sine 70 or any of these other shorter expressions. Only now are we typing this all into the calculator at once. The acceleration, 4.26 meters per second squared. If we substitute that back into the equation we got for A into the t minus 7g sine 70 equals 7a with a little bit of rearranging, and then we substitute our answer of 4.26, we get that tension equals 94.3 newtons. So with a few lines of working out and a very well labeled and used diagram, we get our acceleration, our tension, and earlier on, our normal reaction force.